We're going to conduct today a triaxial stress test using hook triaxial cell. This particular cell allows us to use rock samples, just without basically injecting any fluid into the sample. Those hook cells, just come in different sizes. So basically they range, just from very small sizes in diameter, which allow us, just to test, smaller samples. Then, they go, just through some larger samples, and in our lab, we have the largest hook cell, which allows us to test 6-inch in diameter samples. The hook cells work like this, that the sample is placed inside the triaxial cell. Then we're going to build, confinement, just around the sample. In this particular test, we're going to use a strong limestone rock. And we have previously tested, just samples, just on this rock. And we're getting approximately 100 MPa in uniaxial compressive strength test. So the idea, of this test is that we're going to first start, just with first sample. We're going to build, just some lower confinement. So in this particular case, we're going to start with a confinement of 2.5 megapascals. And then we're going to start, just loading uniaxially the sample. We're going to keep applying uniaxial stress, just on the sample till the sample is going to break. After the sample is going to break, we're going to take a new sample from the same type of rock, and we're going to increase our confinement, just on the sample. In our case, we're going to increase this confinement to 5 MPa, and at the same time, we'll be building up, just the uniaxial load on the sample till the sample is going to break. Theoretically, with each increase in confinement stress, just the uniaxial load when the sample is going to break, just should be higher. Those numbers, just we're going to use, just later on to plot Moore-Coulomb failure envelope. And from that, we're going to extract, just cohesion of the rock and internal angle of friction.